students, today we're going to do an activity to discover what a radian is. There is a PDF in your Schoology folder called Taste the Radian. You're going to want, if you're going to do the activity with me, you're going to want to get a sheet of paper and trace a circle. I just used a plate and traced a circle around here. You're going to fold the paper in both directions so you can find out what the center of the circle is. And then you're going to need something. I'm using Skittles. You can use little Cheerios or chocolate chips or M&Ms or something just little and tiny that you can place across the radius to start with. So in geometry and up until now, you've basically used just angles, just degrees to measure your angles. Using degrees, there's no relationship between the size of the circle, the radius, and the 360 degrees around the circumference. To accommodate this, we're going to use a measurement called a radian, which relates directly back to the radius of the circle. So we're going to go ahead and place our candy or whatever you're using across that radius, and you're going to see how many pieces you can fit across here. Okay, so for my radius, I fit a total of, and it's obviously not going to be perfect, but I'm saying about 7 Skittles is my radius. So depending on the size of your circle, your measurement of how many pieces is going to be different, but it should still work out just fine. So what we're going to do is we're going to then, starting where the circle meets the positive x-axis, so right here where my purple Skittle is, we're going to wrap the number of Skittles we found, these 7, around the outside of the circle. And we're going to make sure to place the diameter of each Skittle directly on the circle. So I'm going to go ahead and line these up. And again, you can pause me at any time and try this. And we're going to try to line these up. I feel like I'm a little bit over here. Move these guys. Obviously, we're dealing with candy. It's not going to be perfect. We're just going to do the best that we can. And then we will go ahead and mark where that candy finished. And we'll use a ruler to make a straight line here. So this line we're going to draw right to the center of the circle, okay? And that's our first little pie wedge here. We're going to do the same thing. We're going to put the rest of the Skittles along the circle from that line we just drew. A little segment there. And that looks about right. We'll go ahead and make another little tick mark there. And from the center, we'll go ahead and hit that edge. Okay, we're going to keep going until we get around the whole circle. So let's keep rolling with this. Okay. And 7 there. Okay. And we'll draw another segment. We'll keep going until we get around the entire circle. And again, whichever little item you used should be perfectly fine as long as you measure that radius carefully. And this will work with any size circle. Okay, and you can't really see that there, sorry. So I'm right here. And let's go ahead and draw this. So we're going to keep on going and try to make it so you can see here what I'm doing. Okay. So I think we're pretty close there. Go ahead and make another segment. And looks like we should at least get one more. So we'll go ahead, keep going around. And we're right about here. Okay, and then we have some space for some Skittles left over. So let's see how many are left. 3 or 4, I would say. Okay, so let's say that we have about 4 Skittles in this little spot here. Okay, so as you're going through the paper and you're working on this, It says, let's see here, repeat until you can no longer fit the candy on the circle. How many complete times were you able to fit the pieces of candy around the circle? So we have 1, 2, 3, 4, 5, 6 complete times. And then we had how many candies remaining? We had 4 candies in this last little part. Okay, so let's see what this looks like as a mixed number. It would be 6 and 4/7. So from here it says to write it as an improper fraction. So we'd have 46/7. The next question says to simplify. This is already simplified. And then let's go ahead and divide to get our decimal. So this is about equal to 6.57. Okay, so the question says, do you recognize any of these numbers? And what I'm hoping you see, and I'm kind of thinking maybe I should have said only 3. No, I still feel 4. So this should be very, very close, and maybe you got closer than I did depending on the size of your circle and the candy you chose. Should be very close to 2 pi. So 2 pi would be 6.28. So we're still pretty darn close here. So if we're thinking about this whole circle is 2 pi, okay, that's how much we're going to have all the way around here. We have 360 degrees, which is the same as 2 pi radians is that entire circle if we're looking at that measure around. Okay, so what do I recognize? I recognize that this is about equal to 2 pi. And again, you might have a little bit closer than I did. Let's see here. So follow-up questions. How many radians are in a circle? 2 pi radians. And then from here, so remember, we're looking at this radius. This was 1 radian, 2 radians, 3, 4, 5, 6, and a bit. That's 2 pi radians. 6 and a bit, that's at 2 pi radians. Okay, calculate the degrees in 1 radian. So I'm looking for what is this angle measure. So if we want to think about this, we could go ahead and say 360 degrees divided by 2 pi radians. And you should get right around 57 degrees. So each one of these wedges here is going to be about 57 degrees. Consider the distance around a circle. We call this the circumference. And remember, the circumference is 2 pi r. Okay, so when we're looking at that 2 pi times whatever the radius is. So we're going to be using a lot of this information when we are working with our trig, when we're working with our unit circle. We're going to be dealing with radians almost exclusively. So we're going to talk more about what a radian is, what a radian means, but when we take that radius and we wrap it around the circle, we're always going to get about 6 of them and a little bit more, which is 2 pi. So this entire circle, we already knew 360 degrees. Now we know 2 pi radians.